Hello students, welcome. This is a video on circuit breakers. This topic I am going to explain in such a way that it is strictly restricted to GATE exam. If you want some theory notes, it will not be available in this video. Let's start. Students, you know that whenever there is a fault in the power system, circuit breaker action will take place. That means the contacts of the circuit breaker will get open. At starting time, that is t equal to 0 plus, there is a arc across the contacts of the circuit breaker while opening. We will learn about that arc. Why? Because it is one of the important theory question. So at the starting, if you see, the voltage is very high, but the distance between the two circuit breaker contacts, it is very low. So I can tell that voltage gradient equal to V by X. Since X is very low, our voltage gradient will be very high. So, due to this voltage gradient, arc is initiated, which is also called as field ionization. Next, after the separation of the circuit breaker contacts, there is a large heat energy developed between these two contacts. Due to this heat energy, our arc is still maintained. This is called as thermal ionization. So students, I can tell that in our circuit breaker, arc is initiated due to field ionization and maintained due to thermal ionization. While coming to the rating of circuit breaker, you will have two kinds of ratings. First one is breaking capacity, another one is making capacity. Students, I will only explain about breaking capacity. Why? Because making capacity is equal to 2.55 times breaking capacity. You can remember this. While coming to breaking capacity, if the circuit breaker is 3-phase, the breaking capacity will be equal to root 3 into V line into I symmetrical. ISY is the symmetrical breaking current. While coming to the 2-phase, breaking capacity will be equal to root 2 into VL into I symmetrical. While coming to the single phase, breaking capacity will be equal to V phase into I phase. Is this okay? And making capacity is equal to 2.55 times the breaking capacity. If we look into the problems, he mentioned that a circuit breaker having ratings as 25 kV, 2000 MVA. What is the making current if the circuit breaker is 2-phase and single phase? Students, whenever you see the name making, first calculate the breaking capacity. Then multiply with 2.55. You will get your answer. So first, while coming to 2-phase, what is the breaking capacity of circuit breaker? Root 2 VL into I breaking current. That is equal to 2000 MVA he mentioned. Now what will be our breaking current? That is 2000 by root 2 into VL is 25 kilovolt. This is in mega, this is in kilo. So our IB will be in kilo ampere. Let it be X. After getting this IB, multiply this X by 2.55. You will get your making current. So I making current equal to 2.55 times X. That's it, kilo ampere. While coming to single phase, V phase into IB equal to 2000 MVA. Since it is single phase, the voltage which he mentioned is phase voltage now. From here, my IB will be equal to 2000 by 25 kilovolt. Sorry, 25 kilovolt. From this, if I want to calculate the making current, let the answer be Y, kilo ampere. I should multiply this with 2.55. Y. This is my making current in the single phase. This is my making current in the 2-phase. If we ask at the 3-phase, then what should you do? Root 3 into IL into I breaking current equal to 2000 MVA. Calculate the I breaking current. where VL is 25 kilovolt. After getting the value of high breaking current, multiply this by 2.55. You will get the value of making current, that's it. And students, to interrupt the current, there is a technique called as current chopping. What we will do is, we will interrupt the current in steps. So as you know, if I represent the transmission line as a very big inductor, if I interrupt the current, the energy transfer takes place. The electromagnetic energy is converted into electrostatic energy. What is electromagnetic energy? That is half Li square. Let I be the value of interrupted current. It is converted into electromagnetic energy, half CV square. What is V? V is nothing but voltage across circuit breaker contact. From this expression, I can tell that V equal to I root over L by C. This is an important formula. If you see this question, the inductance and capacitance of a line are respectively 1 Henry and 0.01 microfarad. If the instantaneous value of interrupted current is 10 ampere, the voltage across breaker contacts is. Wherever you see interrupted, then you should understand that it is actually current chopping, interrupted current. Now what is the formula for voltage? I root over L by C. I is 10 ampere, root over L is 1 Henry and C is 0.01 microfarad, which is equal to 100 kilovolt. And this is the most important topic of the circuit breaker. Students, if you observe, I am assuming transmission line as highly inductive in nature. Whenever there is a fault, let this be fault current. Since this is highly inductive in nature, I can tell that fault current lags the system voltage by 90 degrees, right? So if this is the system voltage, my fault current will be here, lagging the system voltage. While coming to practical case, it is not completely lagging. It is 80 to 90% lagging. So if you observe this diagram, it is mostly lagging. Let us assume that there is a fault current and the circuit breaker started tripping here. So at the instant of tripping, arc is formed. This is the voltage of arc. And let us assume that at this point, arc is completely extinguished. At the point where arc is completely extinguished, since it is a large inductor, students, you know that V equal to L into di by dt. If we interrupt the current across the inductor, you will get impulse voltages. That's why whenever the arc is extinguished, you will get the impulse voltage. And this impulse voltage will die after a certain amount of time. Now, the system voltage at which the arc is extinguished is called as active recovery voltage. And with this, at the instant of arc extinguishing, there will be transient over voltages. That is called as restriking voltage. After certain amount of time, this restriking voltage will die. These transient oscillations will die and they will be equal to the system voltage. This is called as recovery voltage. The blue color line which is appearing, it is called as active recovery voltage at the instant of arc extinguishing. The value of active recovery voltage is E equal to K1, K2, Vm sin theta, where Vm is the maximum voltage per phase. Students, if in the question it is mentioned that 132 kilovolt line to line, then this is the RMS value. For calculating Vm, first you should divide this by root 3. It will be converted into phase value and you should multiply it by root 2. It will be converted into maximum value. Like this you will get your Vm. And K1 is the armature reaction component. He will mention in the question. Next, K2 value we should find out. If fault and neutral both are grounded, then K2 will be equal to 1. K2 is 1 when fault and neutral grounded. And K2 is equal to 1.5 if any one of them is ungrounded. Any one of them is ungrounded. and theta is power factor angle. What are the faults that are grounded? LG, LLG, triple LG. What are the faults that are not grounded? Double L and triple L fault. And the expression for restriking voltage is E into 1 minus cos omega n t, where omega is the frequency of natural oscillations and it is given by 1 by root LC, where L is the total inductance up to the point of fault. C is the capacitance, total capacitance up to the point of fault. This is the expression for restriking voltage. From this, I can tell that maximum restriking voltage is, if I keep t equal to 0, it will become 2. Maximum restriking voltage will be 2E, where E represents the active recovery voltage at this point. This blue color line is E. This black color line is restriking voltage. And if I draw the graph of restriking voltage, it will be like this. Students, you know this total period is 2 pi. So if in the question, if we ask what is the time taken to reach the max restriking voltage, this is the max restriking voltage and this is the time taken to reach maximum restriking voltage. What is this? Omega n into Tp equal to pi. This duration is pi. From this I can tell that my Tp is equal to pi by omega n. Omega is nothing but 1 by root Lc. So Tp is equal to pi root Lc. This is the time taken to reach the maximum restriking voltage. X-axis is time, y-axis is restriking voltage. Since it is 1 minus cos omega nt, it is shifted upwards. Next we should calculate rate of rise of restriking voltage. It is nothing but how much rate it is rising. For that, we need to differentiate this. If we differentiate this restriking voltage, you will get E omega n sin omega n t. From this I can tell that this I am writing as rate of rise of restriking voltage. From this, maximum triple RV will be E into omega n, where E you know how to calculate. Omega n is 1 by root Lc and average rate of rise of restriking voltage will be, for a sinusoidal waveform, if x is the maximum value, average will be 2x by pi. I hope you know this. Here E omega n is the maximum value, so average will be 2 into E omega n by pi. I can also write this as 2E by pi root Lc. Now if you observe here, 2E is the maximum restriking voltage and pi root Lc is the time taken to reach maximum restriking voltage. Now I can also define average RRRV as maximum restriking voltage by time taken to reach the maximum restriking voltage. In question, he may ask in any manner. You should be able to answer it. And students, to decrease this transient oscillations, we will connect a resistor across circuit breaker contacts. That value of resistor is equal to 0.5 root over L by C. You should remember this. And if the value of resistor is less than 0.5 root L by C, then it is called as overdamped condition. If the value of resistor is greater than 0.5 root L by C, then it is in underdamped condition. I mean, in critically damped, if this is our system voltage, our restriking voltage will be like this. In overdamped condition, if this is our system voltage, our restriking voltage will be like this. But in underdamped condition, if this is our system voltage, our restriking voltage will be like this. So, to die out the transient oscillations, our R should be less than or equal to 0.5 root L by C. This is very important point. You will get directly 1 mark questions from this concept. In this question, He is asking the value of resistor required which will give no transient oscillations. So students, what is the value of R? 0.5 root over L by C. L he mentioned as 25 millihenry. F he mentioned as 0.025 microfarad. I think if you solve this question, you will get answer as 500 ohm. If you see this question, a triple L fault occurs at a terminal of circuit breaker. For 132 kV system, the power factor of fault current is 0.8 lagging. Then the value of active recovery voltage across the circuit breaker is. So this is our active recovery voltage. E equal to K1, K2, Vm sin theta. And students, if we didn't mention the value about K1, take it as 1. And if you see K2, he mentioned it is a triple L fault. So it is ungrounded. I can take K2 equal to 1.5 because it is ungrounded. K2 value is 1.5. What is the value of Vm? Vm makes the maximum phase voltage. So if I divide 132k by root 3, it will become phase, and for maximum I should multiply by root 2. And what is theta? Theta is the phase angle. He given cos phi equal to 0.8. Sorry, theta is the power factor angle, not phase angle. Cos phi equal to 0.8. If cos phi is 0.8, what will be sin phi? That will be 0.6. So I can directly take sin theta as 0.6. Now if you multiply all this, you will get 97 kilovolt. And students, in this question, system of 132 kilovolt, 3 phase, power factor of fault is 0.4 and recovery voltage is 0.95 times the full line voltage. Actually students, the recovery voltage should be equal to full load voltage, full line voltage, but it is given it is 0.95 times. This is the value of K1. In this manner, he will mention the value of K1 to us. Next, frequency of restriking transient is 16 kHz. Find triple RV when fault is grounded and fault is ungrounded. So very easy problem. Students, what is the formula for triple RV? 2E by pi root LC. What is the value of E? K1, K2, Vm sin theta. When the fault is grounded, E will be equal to, what is K1? 0.95. Since the fault and neutral both are grounded, K2 is equal to 1. What will be the value of Vm? 132 kilo by root 3 into root 2. And what is the value of sin theta? Sin of cos inverse 0.4. Because cos theta is given as 0.4. I will find the theta from this and I will substitute in sin theta. This is the value of E. Next, how to find pi root LC? It is given that frequency of restriking transient is 16 kHz. It is given in Hz. So, F equal to 1 by 2 pi root LC. From this, 1 by pi root LC is equal to 2 into F. That's it. So my answer will become 2A into 2F. You already know the value of A. F is 16 kHz. This is my answer. The answer will be 6005 into 10 power 6. Students, if you see the units of this, E into F. E is in volt, F is in Hz. Hz is nothing but 1 by second. The units of average RRRV is voltage per second. But there is a term 10 power 6 here. I am removing this and I am writing microsecond. And I am keeping a point here and I am writing this as kilovolt. Now this will become 6.005 kilovolt per microsecond. These are the units of rate of rise of restriking voltage. Next problem is when fault is ungrounded. Students, when fault is ungrounded, this K2 will be equal to 1.5. By keeping the value as 1.5, calculate the RRRV and mention the value in the comment section. In this question, he mentioned time taken to reach peak restriking voltage is 50 microsecond. Peak restriking voltage is 100 kilovolt. What is triple RV? It is very easy. What is triple RV? Peak restriking voltage by time taken to reach the peak restriking voltage, that is 50. Units are kilovolt per microsecond. So the answer is 2 kilovolt per microsecond. Students, this is for now. If a question is asked from circuit breaker, I guarantee you they won't go beyond these concepts. So prepare well, score better. If you like my video, hit the like button, and if you want more videos, do subscribe to my channel, and if you have any doubts, please mention in the comment section. Thank you.